let's see how we can test an algorithm. So first of all, what you need to do is you either need to download the whole project and open it in your favorite IDE, or you clone it with git clone. Then you should see this. If you don't see the README right away, it's right here. We open it, and I will show how to do the setup in IntelliJ, but it should be easy to follow along either way. So we need to set the project SDK to Java 21. Let's go to File, Project Structure. Here we can see I already configured it to Java 21. If not, you can either usually download it or add a folder manually here. So if you did that, click OK. Then we go to File, Settings, Build, Execution, Deployment, Build Tools, and Gradle. We set it like this, with build and run using Gradle and run tests using IntelliJ IDEA. And we set the Gradle JVM to the project SDK right here. Oh, I set the wrong one. Click OK. Then we can see we go to source, algorithm testers, and your implementation. Source, algorithm testers, your implementation. This might not look the same, but don't worry about that. And first of all, we can see an explanation over here. I will just quickly go through it. There should be timestamps down in the video, so you can skip forward if you want. So you can create a new automaton like this. An automaton is a set of states, and you can create a new state like this. And by it being a set of states, I literally mean it is literally a set of states. So yeah, you can use all the set operations like add for adding a new state, or you can loop through it like this for state s in automaton, and you get every state in the variable s. Then going down, you of course have streams available, and you can get a state by name using get. But you usually want to create this state if it does not exist yet, so you can use get or create to do exactly that. Yeah, so here we get or create the state as 3 if it does not exist yet, and save it in the variable as 3. You can also check if the automaton contains a state by name, of course. You can add a successor with the property, with a certain property. So for example, we say s2.add successor with the property a to s3. So this would be s2 with the property a to s3. Okay. We can also add more successors if we need that, with add successors with s. And each state has some properties. I should not name them properties, but for example, a state has a name, and we can access that with s2.name. So we get the name of the state s2. And also if it is an initial or final state. And if we want to, for example, get a set of all successor properties, so A, B, C, or whatever, we can get it with s2.getAllSuccessors. get successor properties, and we get back a set of string, as the successor properties, like we see here, are strings. Or if we want to get all successors for a specific property, we can just use get successors for with that property string. And then we get all A successors. We can also get all successors, but that might not be as useful, because then we might have to filter them again for some specific properties. We can also check if a state has a certain successor or has a certain property. Okay? We can loop through the successors like this with s2.getSuccessors, or we can loop through the successor properties of a certain state with getSuccessor properties. And you're seeing some examples here. Of course, you can also use streams. And then to the special methods, we have here get initial states to get all initial states of the automaton, get final states to get all final states. And we implemented some special methods, like for example filter, where you can filter the automaton for a certain predicate. Here we say we want all states that fulfill the property that successors.size is 1. So we get a set of all states with only one successor. We also implemented any match, all match, or none match. For example, for any match, we want to know if any state has the property A. And then we get back a boolean that tells us if the state has that property. We can also get the alphabet with .getAlphabet. And we implemented some special functions. You can go through most of them on your own, but just to go through one of them. For example, we can say automaton.map, and we're mapping each state to something else. For example, the automaton is a set of states, and we're mapping that to a set of strings by converting each state to state.name. And we have a set of string names. And maybe we want to map states to other states and get an automaton back. Then we should use map states, which maps a state, for example, to its A successor, which does not make much sense, but it's just an example. And if we use the methods that have the postfix states, it collects them automatically back to a finite automaton. And you can also use the finite automaton collector in your streams if you ever want to create a finite automaton out of some states. So, some special functions that you may need. We have a combined name function that combines the names of an arbitrary amount of states, and the reason why you might not want to implement this yourself is because it combines the names in a sorted way. And what I mean by that is, imagine you want to combine the name for states S1, S2, and later you get them in the other order, so S2, S1, and then you have two states, S1, S2 and S2, S1, which you might not want. You only want one state, and this function sorts the names automatically, which is way more convenient. You can also create a pair of states that is particularly useful for one algorithm, I won't say which one, where you can create it with pair.off, and you can access them with pair.left and pair.right. So let's go down to the implementation. Right now you're seeing here that no algorithm is currently implemented, but let's say I implement a very clever is-deterministic algorithm, return false, and then we start the main run configuration. You can choose multiple configurations here, but I would for now advise you to stick with the main run configuration that starts the front end, the servlet, and the algorithm tester. So we click on this, close this, and right here we want to generate some random finite automaton where we want to test our algorithm. So we can just click apply your algorithm, and it should say, oh, we need to choose the algorithm. We implemented is deterministic, apply your algorithm, and it says false. And if we apply some other algorithm that we did not implement, it says algorithm is complete, is not implemented yet. And what you're seeing in the backend for the is deterministic algorithm that was implemented, so it did nothing, and the backend did not crash when we ran the is complete one, but we see that in your implementation 127, exactly this, an exception was thrown, and the exceptions are just printed out to the command line, and you can see here where exactly the exception is coming from and what the problem was. So algorithm is complete, not implemented yet. If we go back, of course this algorithm is horrible. So for example, if I say S1 with A goes to S2, which is most certainly deterministic. For example, if we click the apply algorithm, then it should say true, but our algorithm says false. I wonder why. Maybe our implementation is not complex enough. And we can validate this. I would suggest that you choose a report author. You go to, for example, I will enter Daniel, and we can say validate algorithm is deterministic, and we get the following verdict: 25 tests pass, but 3 fail. So which cases fail? For this automaton, we can just copy it here. Oh no, that's deterministic. But our algorithm returned false when true was expected. Or this case, a more complicated one. Oh. Well. Yeah, so maybe we need to adapt our algorithm. But if we uncheck this, we're seeing all the cases that worked. So for example, this one, this is clearly not deterministic because we're having A in both directions. Yeah, the ones below this line here are just randomly generated algorithms where your implementation is matched against the sample implementation. So those usually work because they are more complicated for the other algorithms, but yeah. And we may want to create a report. I will check this again so we don't see the success cases. I click on validate all. Oh, it takes a while. And then right here we should see in the resources folder the Daniel.report, where we have a timestamp, the current one. Oh, okay. And we see our verdict and what worked and what didn't. Right. You can send this report to someone if you want. And that should have everything in it that you need. So, that's it, I guess. No, one more thing. For some algorithms, you need, like is equivalent, you need two automatons. Let's just create one with A, go to S2, and you can do that using the semicolon. So, for example, press enter, T1 with A going to T2, and those two are obviously equivalent. And then, yeah, we have created two. Oh, we need initial states for this to work probably. You can click apply algorithm, and then it says this algorithm needs initial states to work. The first automaton does not have any, and of course both do not have any. Oh, sorry. Create initial states like this. Yeah. Then we click apply algorithm, and it says true because they're both equivalent. So remember that you can create more than one. You can send over more than one automaton using the semicolon. You can also create more than two, but that might not be as useful as there is no algorithm that needs more than two currently. Yeah, have fun.